Well, hello everyone, and today we'll be seeing one of the problem from Leetcode. It says 4 divisors. The problem goes like, given an integer array nums, return the sum of divisors of the integers in that array that have exactly 4 divisors. If there is no such integer in the array, return 0. So we are provided with few examples. We are given an array 2, 1, 4, 7. 21, 4 and 7. So 21 has 4 divisors like this. 4 has 3, so it is not counted. 7 has 2, so it is not counted. So only valid is 21, which has these many divisors. And if you sum all of them, the result or the output is 32, and that is why our answer is 32. Likewise, we have 32 for 21. If there are two 21s, we'll count both of them, which is 32 plus 32, that is 64. And likewise in this example, there are divisors, but none of the numbers has exactly 4 divisors. That is why we here return 0. So these are the constraints such as, and we are expected to solve this problem. So first thing first, you can go ahead and do a simple thing that hey, you can say that hey, all is that I wanted to count sum, right? Sum, right? I'll return sum, and how I will be doing this is I'll be iterating for each number within nums, and I'll calculating the sum or gets apt sum from this number. But how would you be getting this appropriate sum from this? Like, there are two things here. You have to find you have to have only 4 divisors, and you have to, before that, find the divisors. So one thing to find the divisor is that you can say that hey, I'll just go ahead and from 1 to n, I'll iterate each element and check divisibility. So that can be done, but it's a brute force approach. You don't want it to do that. Why? Because it's time consuming. For if your n value is 1000 or something like that, you don't want to do that. Again, what can be better solution? Better is that you have to understand the nature of divisor, and prior to that you have to understand the limits where the divisor can be. Let's take the example of 21 itself. So 21 has divisors 1, it has 3, it has 7, and it has 21 itself. Now you need to understand till how the divisors are. So you see, divisors always occur in pairs, and this is a statement. There is no if and buts here. The pair of a divisor, what do I mean by that? So if you have any one divisor, you're iterating. Let's take a iterator I, and you hop across a number which is 1. Now you see that hey, 1 is divisible by our number 21. So when I say divisors occur in a pair, that means you have one divisor, it has its pair linked to it. And how do you find this pair? You can find this pair by 21 divided by 1, which is nothing but 21. So if you have a divisor like I, then you have n by I as a next pair. Still confusing, right? So let's take this as an example. You have 6, and I have told you that hey, I have a divisor 2. I don't want you to iterate further and tell me what is the next divisor, or what is yet another divisor. So that's not a big deal, at all, but I want you to find it out. So how would you say that hey, it can be 1, but I don't want 1 and 2s. I don't want you to iterate. I have given you an information that n is 6 and one of the divisor I is 2. Find the another one. So you'll go, hey Aniket, I have 6, I have 2, then I'll just divide it, and I'm sure that it will divide because 2 is for sure a divisor. That means 2 would divide 6, and that will give me 3. And I'm sure that 3 is a divisor because 3 itself divides 6, and the result would be 2. Likewise, I have a next divisor. I have a next divisor as 3 for 2. That means here also for 6 it occurs in a pair. So for 6 it occurred in a pair of 2, 3. I didn't took 1, so if I take 1 it would be 1, 6. Again I have 1, 2, 3. I'll check for 4. 4 is not divisible, 5 is not divisible, and I know 6 is divisible. Now there comes a question now. I know how to find pair element, but do I know first of all till what point I have to look? I mean, yeah, for sure I'm going from 1 to n, but you're saying me that hey, you don't need to approach n, because even if you're not approaching n, even if you're approaching like 1, you are spanning till 6. If you're having 1, you're spanning till 6. If you're having 2, you're spanning till 3. What is the point where I should stop iterating, or I should just say that hey, it's okay because by the pairs I have already iterated this. That means I have also iterated this kind of element. Consider this as a mirror images of this. So what is this point? So mathematically speaking, this point comes to be as square root of the number itself, n. So this is where we have to understand that hey, this is the point where we have to stop our looking, and we have to figure out that hey, beyond this point you would just get duplicates and nothing much, because if you're going ahead and you're iterating till 6, you will get 6 pair as 1, and you have already iterated 1, and which you don't want. So our major concern with brute force approach is that every element check is very consumption, and the span is big. Every element to iterate. So we are not iterating every element, and as a result of that our span is small as well. So this solution can work. So what I'm doing is I have optimized this get apt solution. I wanted to do get apt solution for any number n. What it will do, that it returns sum of divisors only if divisors count is equal to 4, exactly equal to 4. So for that I need two variables, is sum, and which initially would be 0, and count, which initially would be 0. There is one optimization trick. I want you guys to figure it out once prior I'm solving this. First of all, I'll take a square root because that is required. So square root this is required for the maximum limit, mat.sqrt, and I'm taking this as an integer. Cool. So I want you guys to tell me that why I'm doing this. Sqrt into sqrt, if it is equal to n, then return 0. So why this? Why this? Let me tell you, this condition is nothing but a if n is perfect square. Why this condition? So this condition applies because sqrt has is a perfect square. So n is a perfect square with I as its let's say I is equal to sqrt of n. Okay, now we know that I into I is equal to n, and with this pairing logic, if you have I an element, the mirror image or the other pair of I would be I itself. So overall only one element contribution with pair as pair is of same numbers. Cool. What's harm in that then? See, the harm is that we want the count to be exactly 4. So I'm telling that apart from perfect square, apart from I, every other divisor is in pairs. That means it is an even number. So if it is an even number and my perfect square is giving me only 1, then even number plus 1 will give me odd number. So that means I have odd number of count of divisor. That means I have an odd number of count of divisor means, like, let's say I am considering 16, or 16 is a very big number. Let me consider a smaller number as 4. I have 1 occurs with a pair of 4. Cool. I'll go for 2. 2 occur with a pair of 2. Since it is duplicate, I will not consider it. Next is 3. 3 is not divisible. So you see, it is an odd number where we have 3 as a count. So even if you have even if you were having any good number of counts, the +1 factor would spoil it all. So we don't want spoiling, we don't want such kind of cases. So it's a optimization case where I take an early exit if it is a perfect square. Also, I'll do one thing: I is equal to 1, I is less than. How far I wanted to iterate? We have just discussed that I wanted to iterate till sqrt less than or equal to. Anyways, it will never be equal to, but I'll just take it for precautions. Again, it is till this point sqrt. I'll iterate only this array, and for this I wanted to find a pair as well. But before that, I'll say that, hey, if n modulo I is not equal to 0, you're no useful for me, so continue to the next one. But hey, if it is divisible, I wanted to go ahead and increment the count to count plus is equal to 2, because I am storing 2 elements, and sum would equal to I plus n divided by I. This is the pair, 1 element, 2 element, and I am counting 2 elements, so count plus 2. I'll also have an extra check that if a count is greater than 4, then hey, it's no use for me and it's going beyond the limits, return 0. And ultimately, if count is exactly equal to 4, that's what the question demands us, then and then only I'll return sum, else I'll return 0. Let's run this for sample test cases. Okay, let me zoom out a bit. I'm not sure what is going on. Okay, I cannot zoom out it. Okay. Cool. I'm not. Give me a minute. I guess I have to reload the page, baby. I'll reload the page. Yeah. Okay, finally. I'll quickly compile this one. Okay, it is accepted for sample test cases at least. I'm submitting this one, and yeah, it got submitted. I'm not sure why this is happening. It is behaving unexpectedly. So this was a classic example of maths problem. I'm sure that topic tags are also maths, and array as well. Yeah, array. So this was a thing where we considered how we can get appropriate sum. So one thing also we can do it is we can get a prime factors, and based on prime factors you can understand what can be the appropriate divisors based on that. But yeah, I'll leave that to you, and for more such content, math, array, data structure, algorithm related questions, click the video on your right, and I'll see you in the next one.